Yeah, thanks Ken, thanks John. You've answered a few things in your talks, or at least set it up. I'm not going to, we've been working on Uncover and various activities for a little while now, and I don't know if we got the answers to the questions, but this is a bit of a run through of a process of maybe trying to get there. So I'll just quickly go through, you know this stuff up front, but it's actually a little bit sort of important to try and put things in context going forwards. Discovery rates and all that sort of stuff, a couple of Richard's diagrams, but a bit of a different take on them. Uncover, so I'll tell you a little bit about Uncover, its origins and where it is now. The bulk of the talk is actually on a road mapping exercise with a Myra across the industry, and that's it's all about involvement and engagement. Two different words and often mixed up. And then there's 3 slides, I think, on lots of lessons learned in the journey, and I guess that more than anything else is they're put there to try and shortcut the process that we're going through at the moment. And then the last question, I think when you first sent this out, Ken, you said, what's the question? And then the other question you had was, why are we turning discoveries into mines? And there's a couple of intentionally provocative slides at the end. They're probably not as provocative as I thought they were going to be, because John's already talked a bit about them, but I think they're really important questions. They're dumb questions, but we don't answer them. And because we don't answer them, we run into a bit of a problem. Okay, everybody knows this slide. Richard put it together. I actually drew the back on this, the back slide on this in 2006 for the DET-CRC application, so I know a bit about it and the problem with it. But the slides on top, and this is really just, again, to give people the context of why Uncover existed or is even considered in the first place. All of the mines, or the majority of mines, are in the shallow, they're either outcropping or shallow cover, and we keep on looking there. And the reason that we keep on looking there is because that's a better chance of success there than anywhere else, even though we're not very good at it either. Richard's slide, this is just the Australian one, but you could take the world one as well. The important one to look at are the dark blue ones on the bottom. These are new discoveries, so all of these are new discoveries. They're not resources found, they're new discoveries, and that's why people need to think about this. And the number of bigger ones has been dropping, and the amount that we spend has been going up, which is easy, right? No problem. But also, on top of that, the more we spend, the more the small ones we find, which is a problem, because we keep on spending money in brownfields, finding smaller and smaller ones, because the near-surface environment gets depleted of big ones, but we keep on looking and finding more and more smaller ones. And unfortunately, more and more of the smaller ones that we do find, we can't mine in the end game anyway, because they're not economic, but we keep on looking for them. And that's been exaggerated in the last 10 years even more. We keep on spending more, and we find less of the big ones, but we keep on finding more of the small ones. But we keep on looking for the small ones. Okay, so we know this, that the maturing, the near-surface environment, or it's not just the near-surface environment, the outcropping area, we keep on looking in, and it's becoming mature. I mean, there's only so much space between drill holes, and we keep on drilling between them. Eventually, we're going to find really, really small things, but we keep on doing it. That's right. So, but we don't look at underneath in the covered terrains because it's hard. Technically, it's a higher risk, and we're all risk averse. Especially big corporations are getting more and more risk averse, so we don't go look there. So even though we've been spending lots of money, we keep on spending more on brownfields exploration. So that's the challenge, I guess, is to try and go out and explore, improve exploration performance. In other words, being able to find these things under cover. Doesn't have to be really deep cover, just has to be cover. And this could be 5 or 10 metres of sand, as an example. So what was the reaction? So in 2010, the Australian Academy of Science, led by Phil McFadden, probably known geophysicist, he put together a challenge for the Theo Murphy think tank, and it's not a geoscience think tank, it's just a think tank that's put once a year, and in 2010 it was put on improving exploration performance undercover. They held the think tank in Canberra, and an implementation committee was formed. They put the exposure draft. They didn't like that, guess what, it was too prescriptive, so they went back and they went and put the Search in the Deep Earth document out. Now, one thing is, I don't know how many people there, about 120 people, a very, very, very small number of industry people. Most of them were academics, and old grey-haired academics like us, or not all academics, but we're all old and grey-haired. Very few younger people, and not that many women. And that is a key issue that we'll talk about at the end as well. Anyway, industry was not involved. Everybody says that they was engaged. Yeah, they may have been engaged, but they weren't involved in that think tank. They came up with this document, and it was released in 2012, and it was almost regarded as a bit of a Bible. But it, and so I just should say a little bit about that. Out of this was a focus on research and development, targeted improving exploration performance in areas it covers, integrating new data sets and into an international approach. And the objective, quite rightly, was to stimulate collaborative partnerships between industry, academia and the government geoscience community. And this is the only slide, I guess, that I put in it that's a bit of the answer, or what the answer would have uncover. So they came up with 4 key themes. Characterising the cover in a mineral systems approach. Now, I'll talk a bit about that in a minute, but characterising the cover, new knowledge and confidently explore beneath the cover. Are we good at that? No. Let's just be honest, we're not good at it, and we need to do a lot to get better at it. Investigating Australia's lithospheric architecture, whole lithosphere from the upper mantle all the way through to the surface where we actually explore and try and mine. We good at that? No. A lot of people say we are. We're not. We can't join the structures in the upper mantle all the way to the surface. We can't map them. Let's just be honest and say we can't do it. Resolving 4D genomic evolution, metallogenic evolution of Australia. Do we do that? No. People have had a go at it, but we can't do it. And then the last one, and probably the most important one for industry, characterising and detecting distal mineral footprints of all deposits. We're not interested in the thing that deposit footprint itself. We want to know distal mineral footprints, because we're going to go look undercover. We only got a few shots at this, and so when we do sample the basement, where the ore probably is going to be located, we need to know where we are relative to be able to vector towards it. Can we do that? No, we can't. And I think that's a key thing, right? So there are 4 themes that came out of this. Do you see any of those 4 themes that came out of the think tank based on economic evaluation of deposits? Nope. And do you see any of those on there that deals with how we're going to train people and educate people and using these new technologies? No. So the challenge has always been how we take these really good ideas, nice little book, vision, and how do we change those and put them into target maps so we can actually drill holes in the ground and make discoveries. So science R&D, data compilation and new data acquisition. We can't, at the moment, we can't get from here to do this effectively to produce things that actually make a difference so we can make discoveries. And that was the key thing. So in 2014, April 2014, there were a few people in the room that were at this summit that was called by Uncover. And we all got together, industry, academia and government, about 150 of us. And it was really disappointing, because we got the same behaviour. Everybody was competing with everybody else. The researchers, all the universities got up there and told everybody how they were so bloody good. All of the government surveys got up there and they competed with each other. They wanted our business. And industry was only one industry talk anyway, so that wasn't really very fair. But it was really clear, there was no change of behaviour. They weren't going to collaborate. They just wanted a forum to be able to tell everybody why they should go and explore in their area, or go and do research at their institution and not anywhere else. So at that meeting, a few of us got together and said, we've got to change this. So first of all, we needed to change our communication strategy. You'll see a few things that we put together to try and provide some consistency in the way that we talk to people, and not just us. How do we talk to the politicians, and how do we talk to the general community as well? And that seeded the early discussions on putting a real roadmap together. So first up, let's get some communication strategy together. So this is Uncover. So working to a common goal, we need to get better exploration undercover. These are 3 sectors: Australian mining, research community, and the government agencies. And this is intentionally put together to show that they do overlap. But guess what? We don't overlap very much, and there's no commonality here at all. That's true, right? So we were all talking to each other, but not really talking to each other about what the common challenges we had. So then we thought, right, okay, then, this is the key. So how do we get those three groups talking to each other and trying to agree what is in that middle box, what's in here? Right, because we're not all going to have everything that we want in that box, but at least can we agree with what we have in common, not what differentiates us. And not just on new technical, scientific and technology challenges, but also data requirements and data challenges as well. And then get together and see if we can come up with some ideas and some ways to change not just the industry itself, or not just the technology and the science and the data, but the behaviours of how we actually go and explore. And then again, how do we take what we agree on and talk to the internal community? How do we actually have a vocabulary that we can talk to each other? And how do we talk to the rest of the community that actually we impact? We don't do this very well at all, right? We don't go and talk to the non-research community. We don't go and talk to the broader Australian community how it affects them. By the way, they're actually going to pay for some of this because they pay through taxes, and so we need to engage them to justify why we want some money. And why are we going to talk to the Australian government? Can we get in the room with some of these decision makers and have an intelligent conversation with them? So that was a pretty important communications tool as well. So out of that came the roadmap, the idea of a roadmap to really get in, to engage industry between the three different communities for the need of a roadmap. And it's known that they're pretty well known for being successful, effective tools to address pretty complex challenges. I'd urge anybody that doesn't know anything about roadmaps to go onto the NASA website and look at that roadmap. It is absolutely brilliant. That shows that's a vision of what the industry needs to be and where it needs to go to at least address some of the challenges that are in front of us. The reason that we did it through Amira, I didn't work for Amira, but the reason that we did it with Amira is because that's their job. They're the guys that are supposed to broker between industry and the research community. So we went to them, let's not come up with a completely different mechanism, let's use the mechanism we already have. And they had experience in putting roadmaps together, the copper roadmap, the aluminium roadmap, the drilling roadmap that led to the DTCRC. So that's why I went to Amira. The roadmap, industry-driven, involved participants in the three different sectors. It was open to everybody, not just the Amira members, and that was pretty important. And the reason that was because it was going to be a public document at the end. It wasn't going to get squirreled away in the Amira archives, or it wasn't going to in the sponsors' archive. This was going to be a public document. And it was endorsed by Uncover, and it was actually trying to build on. We weren't going to, come into something that competed with Uncover. We just wanted to take Uncover's ideas and just expand them. Stage one was to get industry and decide what it wanted to put in that box. These guys were involved, the government and the research community were involved, but the first one was to get these guys in a room and say, what do we want to put in this box in terms of research, technology and data? And then to prioritise them. We came up with a list of priorities, activities and stuff. We delivered that in July 2015. Stage two, which started mid last year and is about to finish at the end of this month. And it will get launched and delivered. And we involved the government and the research sector on putting together a program, a portfolio, I guess, of research, technology and data initiatives. How do we get the data that we already have and get it into a state that we can actually use it and interrogate it? Which are the important bits and which are the key bits of data? Which is actually going to, unfortunately, involve quite a lot of data compilation. And in that compilation, we'll actually decide which data we want and which data is not useful because it's old data or was collected with irrelevant and non-applicable detection limits and all that sort of stuff. So a big investment up front. And then at the end of that, we talk about research vehicles and funding options and all that sort of stuff. But basically, we talk around in circles on that bottom bit, and we need to involve people at the next pay grade up from us, to be quite honest. We need to involve CEOs of companies, and we need to involve high-level ministers and whatever. Anyway. So at the moment, we haven't delivered it yet, so I can't say what we have done. I can just say what's happening. It's definitely increased stakeholder interaction and collaboration. There's a lot more detail and granularity that's come out. In other words, what we're actually going to do, rather than just talk about what we'd like to do. We've come up with some clear priorities, and that scale reduction is driving research, especially in the predictive part of the targeting. We're going to look undercover, so you actually can't detect too many things. You need to predict first before you start going and collecting data undercover, because it's an expensive process. And probably the biggest thing that came out of the stage 1 for me, and it's going to be even more critical in stage 2, is the complexity between them, between data, between technology, and between new research, and what that does in decision making and behaviour. I won't show you now, and I'm happy to show anybody on the dependency mapping. That is actually critical. It's going to be critical in stage 2, and I think something called dependency mapping is going to be even more critical going forwards if we're going to make some of these solutions, and I'll talk a little bit about that in a second. So these are all the lessons. So 3 pages of them. First of all, the broad geoscience community demonstrated a willingness to contribute to a shared vision. They wanted to do it. They just wanted a vehicle to do it in. They didn't have one. We kept on throwing rocks at each other at summits and conferences. They just wanted a shared structure. Having a structure and engagement and involvement process was a step forward. There was a void for people. They wanted something, but they didn't have something, and the roadmap provided them that opportunity. One-on-one interaction enabled levels down involvement, and what I say by that is it's not just talking to us in the room, it's not just talking to grey-haired people, grey-haired males, it's talking to real people that work in companies and in universities and in technology providers. And diversity, not just in age, not just talking to all the same age, talking right down to guys and girls doing their PhDs right now, and talking to girls especially. We need to involve women a lot more in this conversation. We're not doing it, and experience levels. We engineered frequent, and I mean physical, so face to face rather than on the phone, rather than on conferences, teleconferences, and all that sort of stuff. So we got the end user companies and the exploration guys and the researchers together, and we got this whole conversation on applicability. What can you use it? Can you use it? And reality. Can you develop it? Is it feasible to develop what you want to do? And we're getting there, but it's a long drawn out process, and it also allows us to manage expectations. And contrary to our expectations, that we thought it would be really frosty up front, which it was a little bit in the first few meetings. I think the longer it went, the more people we involved, then the people were a lot more willing to contribute in a public sense and in a room of 50 people, but most of the most important interactions happened one-on-one, but we still gave them the opportunity. Having an early agreed vision, mission and objectives, all that sort of stuff helped with focus, so we could always refer back to what we were trying to do here. But of course, visions or wish lists are easier to communicate than actually designing the solutions. We can talk lots, but when it actually comes down to like designing some solutions that have costed and time, with an idea of time on them, it's a bit harder, but we're getting there. Common messaging, consistent messaging are essential, both internally and externally. If we say we're going to do something internally and externally, then we have to do it. We can't just say we're going to do it and then, we didn't actually get there. We have to do it. The next point's really important. If you involve more people, you regress to small incremental improvements, because it's the consensus. But we've got to involve the community to get agreement and support. So you have to do it. The key in this, I think, was that who pulls this together? A small number of experienced people, and they self-selected themselves, right? So we didn't go out and ask people to do this. They self-selected and they want to do it. Most of us did this pro bono. We didn't get paid for it. I mean, I get paid a little bit by the roadmap and Amara to do this. But the other people that we pulled in, especially in stage 2, are experts. Most of them are doing it for nothing. They self-selected themselves. And they're interested in improving exploration performance. And some of them are younger, but most of them are sort of seasoned professionals, 45 plus. And in that, it's important, that last bit, we were prepared to highlight what we don't know. So all the time, we feel like we have to have the solutions, but I think a few of us have to be prepared to say that we can't do that, and that we're not very good at it. Collaboration, the term collaboration I think is defined by different people and different individuals in different sectors. To a group of people, contribution means we get together, we talk a lot, we contribute ideas, we then get together and we contribute and come up with ideas on solutions. And we wait and we deliver those. There's another group of people that say we all get together, we collaborate and input our own ideas, and then we get those ideas, we take them away, we brand them as our own, and then we compete with the rest of us. That isn't collaboration. And there's a behaviour that there's a lot of people doing that. I don't know about anywhere else, but in Australia right now, there's a lot of people taking those early ideas, rebranding them as their own, stealing them, and competing with us. We've got a bit of a problem there. Again, closer we get to the end, the competition's taking over. People can see opportunity for themselves, or they can see it to the benefit of their own organisation, and they're taking it, but they're not doing it for the greater good, the exploration community, the geoscience community. One of the things that I think both John and Ken said was we believe that we can do it. We're resourceful. Geoscientists are pretty resourceful people. They go out and they design and they develop their own solutions to things. And there's a thing called law of the instrument. I don't know if anybody's heard of this. It's also called Maslow's hammer. And we assume our experience is the most important. And in geoscience, what I mean is we come up with a geological problem, and because we're a geophysicist, we design what we think is the best geophysical solution to that problem. If you're a geochemist, you do a geochemical solution to that problem. If you're a geologist, you do the geological solution to that problem. But at any point, do we all get together and say, out of all of these, which is the best way to solve it? And is it one or the other, or is it a mixture of all of them? But we never do that. We seem to prioritise science and research on what we know and what we're good at, not on developing science and what we need to improve. So how much work has gone into isotopic work in the last 10 years? An absolute ton. But we're good at it. And we keep on doing more and more of it on smaller and smaller samples and smaller and smaller areas. And the last one is a bit of a positive one, I suppose. Involvement beats engagement. I was actually going to put, this would be funny, I was actually going to put involvement trumps engagement, but I don't think I can use that. So, but I think that's really important. So just simply engaging people and feeling like they have a problem, or that they have a involvement in the thing, it's not good enough. You actually have to physically get them and involve them. And unless you can involve them, you're not going to make any progress. Then the second bit, I'll just talk a few slides in this, not too much, won't take too much more time. This whole problem between resource and mine transition. So less of the new discovered resources are converted into new mines, and I think that is true. I mean, you can see that, right? And I would say, we just have to ask ourselves a series of questions here. Are we exploring for resources, or are we exploring for mines? That is a whole can of worms that we need to open, and it's going to cause a few problems, but we need to open that. Second one is, can we mine what we find? And there's a couple of reasons for asking that question. Can we mine? We might find what we believe is an economic deposit, but if it's got 100,000 people living on it, do we really think that we can mine it? If it's got if it's got a salmon fishing on top of it, should we try and mine it? Should we even try and put a resource and reserve on it? Where are we adding resources? Are we adding resources, new resources out in greenfields exploration, or are we adding more resources to existing projects, existing mines? Are we adding resources? This is a good question. Are we adding resources to mines that have been closed because they weren't economic anymore? So we're adding more to residual resources under repair, and we keep on doing it, and we keep on getting rewarded for it. Are those decisions on exploration fact-based, or are they just based on ignorance? Now, what I mean by that is Do we consider economics before we start exploring? Or do we consider economics but we ignore them? And is reward driving exploration behaviour? If you work for a major company and you get caught trying to find resources that you know are economic, then generally you do get found out. You get found out now. If you're an exploration company looking for resources, you get rewarded for finding a new discovery or a new resource. But do you ever intend having it mined? And then the considerations for that, economic search space. Do we really want to go and look for porphyry deposit with 1,000-metre holes? If you want to go and find an economic porphyry deposit that's for underground mineable, you have less than, if you just look at all the porphyry deposits on the planet, there's less than 1.1% of those porphyries that have got the required grade for an underground resource. But we still keep on drilling 1,000-metre holes looking for porphyries. Resource quality and size versus infrastructure. John said this. Yeah, infrastructure actually does matter. You can't go and look for 100,000 ounces in the middle of nowhere. You've got no way of getting it out the ground, but we keep on doing it. And then the last one is social license considerations. So I've only got two more slides on a bit of this. Three. This is Richard's story. And when I first showed it, it said new deposits, but this is only half the story. These are only the new ones, right? So these are new discoveries. So this is a slide from just the Australian one, but you could do this globally. But so this is the solid line is the growth in resources just summed up for the whole of Australia. And Geoscience Australia do this for us actually, and they give us the information that we can do this. They have a real problem how they report it, but that's what they do. So between, 2000s and whatever, look at the massive growth in tons of gold. So 2,000 tons, 10,000 tons, you've got a massive improvement in the resources in gold in the last 20 years, 25 years. The slide, this one on the bottom, is the production at the same scale. All those, what I did is I multiplied that by 10 so you could actually see it a little bit, so it definitely is flat. So we added all these resources and it's having zero impact on production. What does that say? It means we're finding uneconomic ounces. Because if they were economic, especially here, we'd have a massive kick up in here, right? When the gold price was at 1,800, 2,000 bucks in Aussie dollars. Nothing happened. So we're finding all these ounces and none of them are economic. And the last slide, I think John sent this around, John Sykes' slide. I love this slide actually because we used to have just here, right? We didn't consider this bit accessibility, we just considered this. If it was discovered, accessible, and not economic, or it was discovered, accessible, and economic, right? So we just used to think about that. Adding the third dimension, accessible, is a pretty important process to go through, because I think we can all think of things, if we just went through, just step back, short distance, we all step back and said, we know projects that have resources in here that are both discovered and they're economic, they're quality resources in here. But did anybody ever ask the question, can we mine them if we get them? We know there are projects that we would put in here that have just gone back in here. They're in this box, in this red box at the back. We're putting lots of money into outlining resources in lots of commodities that realistically we can't mine, and they're mostly because of access for social conditions and environmental considerations. But we keep on putting them in this box, but we don't fess up or put them where we should, which is in this box here. Because if we did put them in that box, the guys that actually gave us the money wouldn't give us any more money. They'd stop giving us the money because they say, can you mine it? No, we'll stop it. And there's a really good example here in Alaska, which I'm not going to talk about too much, but I think most people know what I'm talking about. It was put in this box for a long time and it's back in here now. There's one of these in the Philippines. It's been in this box for a long time, it's in this box right now. So that's it. I don't have too much. I can show people on the roadmap and all that sort of stuff if they want to, and some other background information, but the next afternoon will be really exciting.
Okay, thanks Robbie.